Hello. Today I am with a question. It's a current lecture question. Obviously, you can read it, right? So, in the question, yes, they are asking us to find the potential. Yes, the reading of the voltmeter, and they are telling us it's an ideal voltmeter. The distance is infinity, right? So try to get the answer. Actually, this is from a pilot paper question. Actually, from the pilot paper platform, and I find this question is actually it's not that hard, but as I always say, it's not that hard. But you have to, if you want to do it quickly, actually, you have to put certain effort to do it. So let's try to get the answer. So I'm suggesting you to try it first. So I hope you have tried it now. Then let's try to get the answer. Maybe your method will be faster than mine, but let's try to see the answer. Right. So what I can see here is actually symmetric towards both sides, right? It's symmetric. So let's try to simplify this side. Right? What I'm trying to do is, I can start from this end. See? So they're asking us to find the potential difference across this. So whatever the plan we are doing, we need to add, right? We need to find the equivalent resistance first. So let's try to find the equivalent resistance. So I'm starting from here because this is the only end where I can find easily two series or parallel resistors. Others are actually connected in so many ways, so I cannot find out which one is what are the resistors that are parallel and that are series. So from here, these two, yes. Basically, these two are in series. This 5 ohms and this 5 ohms. So, you know the theories. We can easily add them. 5 plus 5, that's 10. And then again, that 10 comes over here. Like this. 10 ohms. That 10 ohms and this. Already we have 10 ohms here. These two are parallel. So, I hope you know the theories. So, when we add two parallel resistors, 1 OR plus 1 OR, similar resistors, R dash will be common denominator R, 1 plus 1 OR dash, so R dash equals R by 2. That means similar equal value resistors, when we add them in series, in parallel, actually we have to divide it by 2, right? So you should hope knowing that. So 10 plus 10, that becomes 5, right? 5, that 5 and this 5, 5, that's 10. So here I get a 10 ohms, right? That particular 10 ohms, and we already have 10 ohms, we add them in parallel, in series, parallel of course, 10, again we get 10 divided by 2, 5. That 5 and this 5, 10, and 10 again, we get another 10 here. That 10 ohms and this 10 ohms, again we get 5 ohms here. That 5 ohms and already we have 5 ohms, 10 ohms. That becomes another 10 ohms. That 10 ohms and this 10 ohms, that's 5 ohms. So it's symmetric. So we have to assume from this side we get the very same. So this 10 ohms becomes 5 ohms. So we have this and we have this. 5. These three are in series, so all together we can add them. It's 15 ohms, and inside we have interresistance 1 ohms. So current, of course, outside we have interresistance here. So potential that goes outside is E minus IR, right? E basically 16 I, of course, 16 divided by 1 plus 15, 16, that's 1 ampere. So 1 into interresistance 1, so it's 15 volt. So out of this cell, the potential difference between the terminals will be 15 volt, and then the voltmeter will read 15 volts. Easy answer. You can, if you have practiced it properly, you can easily get to this answer. I'm just showing you an example actually. The way to do a question, actually practice. If you have done the practice, so in so many, you should understand, you should recognize the symmetric of the equation, and you should be able to, where you have to start the question, right? So this is where you start the question. So that, of course, you have to identify, and you can easily do the question. And similar, like several types of theories will come together for sure. Should know the theories with internal resistance of a cell theory, and once you add all these together, we have the answer. We have the winner. So practice. Current electricity question is a language. Current electricity is a language. So practice doing current electricity questions. It will help towards electronics questions as well. So take my advice, practice. I hope you have tried all those questions now. You have learned something from it. And always remember that practice makes it permanent. So what we have to do is we have to practice something correct, something right? Again and again we have to repeat trying it, so it will become permanent. So practice, right?